Assalamualaikum and good evening to all my fellow friends and lecturers. Today our group will present about tensile tests. We from Group C from Section 10 and our lecturer is Mr. HASRUL bin ISMAIL and Siti AISYAH bin Abdul RAZAK, and our group member is Muhammad Azam bin Muhammad AZMI, which is me, Muhammad ALIMI bin AZMI, Muhammad ALIF NAZMI bin NORDIN, Muhammad Amirdanial bin Hamzah, and last Muhammad FADLIE bin SHAHADAN. Now, I'm going to talk about additional theory, tensile testing, a form of tensions testing and is destructive engineering and materials science test whereby control tensions is applied to a sample until it fully fails. It is used to find out how strong a material is and also how much it can be stretched before it breaks. This test method is used to determine yield strength, ultimate tensile strength, ductility, strength hardening characteristic, Young modulus, and Poisson's ratio. Next is stress and strain. What is stress? Stress is used to express the loading in terms of force applied to a certain cross-sectional area of an object. Stress is the applied force or system of forces that tends to deform a body and for the material. Stress is the internal distributions of forces within a body that balance and react to the load applied to it. While strain is the response of a system to an applied stress. When a material is loaded with force, it produces a stress, which then causes a material to deform. Now we move to stress-strain relationship. Tensile loading on material causes the materials to undergo deformations. The kind of deformations can either be elastic or the plastic deformations. The elastic deformation is characterized by linear relationship between the extensions and applied load. Here you can see formula for stress and strain. Next is Young modulus. The Young modulus is a property of the material that tells us how easily it can stretch and deform and is defined as the ratio of tensile stress to tensile strain. And also for this one, you can see the formula for Young modulus. Now yield strength. What is yield strength? Yield strength refers to an indication of maximum stress that can be developed in a material without causing plastic deformations. It is the stress at which a material exhibits a specified permanent deformations and is practical approximations of the elastic limit. Then ultimate tensile strength. Ultimate tensile strength is the maximum stress that a material can withstand while being stretched or pulled before breaking. Last, ductility. Ductility is the ability of a material to sustain a large permanent deformations under a tensile load up to the point of fracture, or the relative ability of a material to be stretched plastically at room temperature without fracturing. Now we're going to talk about result. As you can see there, above result is for before testing. Diameter before testing for aluminium is 8.18 mm and length before testing for aluminium is 80.66 mm. While for mild steel, before testing diameter is 8.21 mm and length before testing for mild steel is 80.91 mm. Now we're going to move to result below, which is for after testing. Diameter after testing for aluminium is 5.28 mm. Length for aluminium after testing is 94.62 mm. While for mild steel is diameter after testing is 5.34 mm and length for mild steel after testing is 93.26 mm. And now I will hand over next part to my friends. Thank you.
Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Alif ALIMI bin AZMI. My matrix number is CD210267. Okay, today I will present about the observation about tensile testing. So the first point is the metals with good ductility normally exhibit so-called a cup and cone fracture characteristic observed on either halves of a broken specimen, as illustrated in Figure 8. Next, necking starts when the stress strain curve has passed the maximum point where plastic deformation is no longer uniform. The third one, across the necking area within the specimen gauge leg, normally located in the middle, microvoids are formed, enlarged, and then merged to each other as the load is increased. The next one is this creates a crack having a plane perpendicular to the applied tensile stress. This shear plane then joins with the former crack to generate the cup and cone fracture as demonstrated in Figure 8. This type of fracture surface signifies high energy absorption occurring during the fracture process due to large amount of plastic deformation taking place, also indicating good tensile ductility. Metals such as aluminium and copper normally exhibit ductile fracture behavior due to high number of slip systems available for plastic deformation. For brittle metals or metals that fail at relatively low temperature, that fracture surface usually appear bright and consist of flat areas of brittle faces when examined under SEM as illustrated in Figure 10. In summary, tensile properties should be considered as important design parameters for the selection of engineering materials for their design application. So we need to choose the type when we have a project or we do something. We need to consider the specimen or the material we're using. So next is I show you the figure that show us about the specimen that we test on the tensile testing. So the figure show us about the specimen. Okay, we pull the specimen together, it's pulled out. Okay, the necking, where the Figure 8 show us about the necking, microvoid formation and coalescence, crack propagation along shear and plane, typical cup and cone fracture. Okay. Then we can see the structure of the specimen also in Figure 9 and Figure 10. We can see the structure from the specimen is ductility. Okay. Okay, that's all from me, and thank you.
Assalamualaikum and salam sejahtera. I would like to present about the calculation, and forgot to say my name. My name is Muhammad Amirdanial bin Hamzah. Matric number CD210308. Okay, next. In order to calculate the Young modulus E, a graph stress against strain have to be drawn for both aluminium and mild steel. Okay, this is about our calculation in our lab report. Okay, next. Okay, the first one I would like to present is about aluminium. How we get the strain, and stress, and all of it. Okay, 10 random value of applied force and elongation were, were taken along the applied force against elongation curve, and result is recorded in the table below. This is the table. Apply force with the elongation. This is the force that we apply to our aluminium rod. This is the force applied to our aluminium. This is elongation that yang berlaku pada the aluminium. Okay, the second table is the value of stress and strain are able to obtain by using the data above. This is stress and strain. To calculate stress equal this force divided by area. Area are given when calculate the diameter and the length of the rod aluminium. Okay, the strain equal to delta L divided by original length. Elongation, this is elongation. Delta L elongation. This data divided by the original length. That my friends would like to present in our result. Have the data of the length of the aluminium. Okay. These two tables are made from our tensile test of the machine. This is the result that come out with the graphs, and this is data that we recorded to make a lab report. Okay, next. Okay, next is the area. This is the area aluminium specimen that we get from the tensile test machine. The value is 52.55 millimeter square or 0.05255 meter square. Okay, this is 3 calculations that we need to do for our lab report group. Okay, the first one I would like to explain is the Young modulus. We use this equation to find the Young modulus value. Okay, this is the value that we insert from the table that I explained before into the formula Young modulus, and then we get the answer is 25 gigapascal. Okay, the second is percentage reduction of area. Okay, we use this equation to get the percentage reduction of area. This is area of our aluminium specimen. This is from this we insert into this. This is the what we call after test area of the specimen is before. This initial, after, before, after. Then we get the answer after insert the value. We get 58.02%. Okay, the third equation is percentage reduction of elongation or EL. Okay, we use this equation, length before, and after, divided minus after, divided by length after. Okay, we use this equation and we insert the value length before and after. I'm sorry. Okay, this is length. This is Okay, I'm sorry. This is the length of after, and this is before. Before and after. After we minus before, and then we get the percentage of the elongation. How long the elongation after the tensile test be applied to our aluminium specimen. Okay, this is uh, the final percentage of elongation, 16.8%. Okay, next. Okay, this slide we focus about the mild steel. The first one that I explained is about aluminium. Okay, this is the second experiment is about mild steel rod. They're the same using the tensile test machine. Okay, the mild steel. 10 random value of applied force and elongation were taken along. The applied force against elongation curve and result is recorded in the table below. This is the table below. This is the force that we apply to our mild steel in the tensile test machine. This is the elongation that from normal length, original length to elongate. This is the result that from the machine. We get this result from the table that we get from the machine. Okay, the second table, value of stress and strain are able to obtain by using the data above. This is the data. The data that I get from the from this equation. P we get from here, area we get from the machine. From the machine that I will explain where is the area. This is the strain. Strain that we get elongation divided by L, original length, that we get before we test the mild steel. Okay, next. Okay, next is this is the calculation that we get. The same calculation from the aluminium that and the different data, different value that we get, because it's the different steel. That is before I mentioned is the aluminium. This is the mild steel. Okay, the first equation same. Yang modulus, we use this equation, we insert the data from the modulus of elasticity from the graph that we get from the machine tensile test. Okay, we get the value 53 gigapascal. The second, the percentage reduction of the area. We use the same and insert the equation that we get, area before and after, and we divide times 100 and we get 58.48%. Okay, the third one, percentage reduction of elongation. We use the same equation. Okay, we insert the data before elongation length and after. This is the after elongation minus before. Okay, and then we get the percentage of the elongation before and after. The elongation is 15.45% from the original length. Okay, thank you from me, Muhammad Amirdanial bin Hamzah. Okay, we send next to my friends. Okay, thank you.
Saya Muhammad NAZMI, CD 210-297. About discussion. In discussion, they are given two questions. Number one is explain the advantage of mild steel in comparison with aluminium in terms of Young modulus, zero strength, and ultimate tensile strength. According to the graph strength and strain, my steel has a greater Young modulus value is 53 gigapascal, then aluminium is 35 gigapascal. As a result, we can see that my steel is stiffer and more difficult to cripple than aluminium. When compared to aluminium, my steel has a greater yield strength, 480 megapascal, and aluminium is 480 megapascal. It demonstrates that my steel can withstand higher strain in addition when compared to aluminium. My steel has a greater ultimate tensile strength, that is 498 megapascal, and aluminium 209 megapascal. My steel has been shown to bear more tension before necking. Next is list all the possible source of error, including error in load cell, cross-sectional dimension, and gauge measurement. How does this error affect the obtained result? The systematic and random error are two types of error that might occur. Systematic mistake, such as incorrect specimen diameter measure using vernier caliper. This inaccuracy may cause variation in the overall stress values. Specimen area, Young modulus, the random mistake will follow. The random mistake such as a vision that is not perpendicular to the vernier caliper reading. This inaccuracy can be avoided by taking 3 or more readings. That's it.
My name is MOHD bin SHAHADAN and my metric number is CD210056. So for the conclusion is tensile testing is a way of determining how something will react when it's pulled apart when a force is applied to it in tension. Tensile testing is one of the simplest and most widely used mechanical tests. By measuring the force required to elongate a specimen to breaking point, material properties can be determined that will allow designers and quality managers to predict how material and product will behave in their intended applications. We were able to successfully tensile testing aluminium and mild steel using the universal testing machine. From the data obtained, we were able to successfully obtain the Young modulus, ultimate tensile strength and yield stress values of the two metals. By comparing the values of the two metals, we can see that my steel has higher values, which means it is stronger and more ductile than aluminium. Thank you.